This is Software Engineering Radio, the podcast for professional developers on the web at se-radio.net. SE Radio is brought to you by the IEEE Computer Society and by IEEE Software Magazine. Online at computer.org/software.
Hello, everybody. In today's podcast, I have the pleasure of introducing Brian Okken. Brian is the author of the Python Testing with PyTest a book, and this is the subject of this, which is PyTest, and Python testing will be the topic of today's podcast. A little bit about Brian. He is a passionate Pythonista who loves to talk about Python and testing, and he is also a podcast host of his own. He has a podcast called Test and Code, and he's also the co-host of the Python Bytes podcast, which I personally listen to. It's a very good podcast. You should go and check out if you ever get a chance. Welcome to the show, Brian. How are you today?
I'm great. Thanks for that nice introduction.
Great. So just to lead into the first thing, so just for everybody, what is PyTest and why should I care about PyTest as a testing framework?
Well, okay. So first, you kind of answered the first part. It is a testing framework. And hopefully you care about testing your code. Now, sometimes we have software engineers that we have to convince that they should test their code. So let's assume that you know that you should. Well, maybe we shouldn't assume that. So I like to be proud of the code I write, and I like to be able to change it. I like to get the first pass done and then be able to play with it, change it, make it something I'm proud of. And a testing framework allows me the freedom to do that because I know once I have all the code working according to my tests, then I can play with it. I can change it and refactor it, and it'll still run. So that's one of the main reasons why I like using a testing framework. And PyTest in particular is really easy to start because it's just little test functions. So you can just start right away with just writing test underscore something and as a function and write some code there that exercises your code under test. And that's it. You've got a test. So you can get started really easily, but then you can extend it and have basically the most complicated test suite I can think of you can do in PyTest. And so you can start easily and it grows with you. So.
Awesome. So as I understand it, then PyTest has a very simple setup and it is convention based. So you do test underscore in front of your file and it'll automatically pick up that file as a test file, correct?
Yeah, so the test underscore is both the files and the function names. You can change that. You can have different things. If you like to have the underscore test at the end of the file or at the end of the function name, you can change that, but most people don't. They're good with the convention.
Right. So Python famously is a batteries included kind of language, right? And we know that there is a testing framework built into Python. Could you maybe contrast PyTest and how easy it is versus the regular unit test mocking?
Yeah, so unittest is actually an incredible piece of software also. So unittest is the batteries included version. And partly it's good to have a testing framework within the standard library so it can be used to test Python itself and the rest of the standard library. So, but it's very different than working with PyTest. And if there's a notion of an XUnit style of test framework, and unittest is one of those. And what that style is you have a base class, a base test class that has, and then with that, it's a naming convention as well. You derive from that base class, and then you implement test methods, and then the test framework runs those methods that you fill in. Now, because it's a base class and you're working within a class system, you've got that's where your setup and teardown go is within the class. And then also with the assert methods are part of that. PyTest is one of the big differences is that generally people don't use classes with PyTest. You can even use unittest as a base class if you want to, but you don't have to base it on anything. You can put them in classes, but it's more of a container to hold your test code in. There's actually a lot of Python developers that are using it every day, but they don't create their own classes for anything else. So one of the reasons why I love to have people, especially in that situation, use PyTest is because that's a hurdle. I've heard from a lot of people of, if I use unittest, I have to go learn about object-oriented programming. You don't really. Using unittest doesn't require you to know very much about object-oriented programming. but that's kind of a barrier for some people. So with PyTest, you don't have to. So that's one of the big differences. The other big noticeable difference is that the assert method. So PyTest just uses the built-in Python assert method. And then under the hood, there are helper functions that tear it apart and make it so that you can see what failed. If when a failure happens, you want to be able to, like, let's say if I say assert A equals B, if that's not true, I'd like to be able to see what A and B were, and PyTest gives you that. Whereas if you try to do that, just that normal bare assert within unit test, you'll just get, false is not true, which isn't very helpful. So unit test got around that by doing a whole bunch of assert methods, extra ones like assert equals, assert not equals. There's a whole slew of them. And then PyTest kind of avoids that by having some under the hood stuff going on. It actually rewrites your source code for you while it's we're getting into the weeds, but when Python runs, it creates bytecode. And in that bytecode process, PyTest can intercept that and turn asserts that are in your tests, or there's other ways to get other code in there, but mostly the asserts in your test. To take those assert calls and interrupt the bytecode translation and call these other helper functions that allow it to make a better assert output.
Awesome. Right. So, like you said, it's a little bit low level and into the weeds, but I think it kind of illustrates the philosophy of PyTest, which is kind of like to optimize for developer happiness and developer users, right? So it's kind of very focused on making the usability of testing very good for a developer.
Yes, and then the readability of the test. So when you're reading a test, you can, and that's a big thing around the PyTest philosophy, is to make tests very readable. So we can have just normal asserts. They just look natural in your code. And then you're hopefully getting extra stuff out of your test. So the test is really focused on really what part of the system you're testing right now.
Right. So usually when you kind of try to start testing any kind of non-trivial system, more than like a simple Python script, but even sometimes simple Python scripts as well, you need to do some sort of testing setup and tear down. There might be a database connection to create, or even kind of mock something or do something with an API. How does setup and tear down work with PyTest? So what are the concepts there?
That's another good comparison with PyTest and XUnit style frameworks, because an XUnit style framework traditionally will have like special setup and teardown. They're actually called that, setup and teardown, or setup class and teardown class. And those methods within, and the difference really between setup and setup class is whether or not the framework calls those functions before every test or just before and after the class. So if I've got, like, say, 3 methods within a class, do I call it once for all 3 methods? Or so there's the XUnit style is really around like having these hooks that you can put code in for before and after your test is run. The difficulty often comes in with, like, sometimes that's not enough levels. So like the database example that you brought up, that's a very common one. I want to connect to a database, and setting it up, connecting it, maybe filling it with a whole bunch of dummy data so that I can run some tests on it. That's kind of a costly thing that I don't really want to do for absolutely every test. So I can set that up once for all of my tests, and then any other test that needs to use that can grab that and maybe reset it to a known state. And that's cheaper than creating the whole thing. So I can maybe roll back transactions or somehow reset it to a known state. Now, within this 2-level thing is possible within XUnit frameworks, but you have to take advantage of like class and method level setup and teardown. But it's you have to kind of do the paperwork yourself. Whereas in PyTest, you can do that within PyTest, but the preferred way is to use fixtures. And fixtures are a named thing. So a test that needs the database or needs a clean database can just have a fixture named that, like clean database or something. Now that can be in different scopes. So the fixtures can be in different scopes. And by that meaning, we've got function, class, module, package, and session, so that you can have like a fixture used by all of your test code, even if they're in different files, different classes, wherever, they can share the same database connection. That's extremely powerful. It also makes it so that you can easily build these things up, because fixtures can depend on other fixtures. So I can have like a string of these, and the test itself only knows the last one it needs. It can have more than one, but if it just needs, I need a clean database connection, it doesn't have to care what all the prior stuff is.
So it's almost like Lego bricks, right? You kind of build a hierarchy, and then the test basically takes a particular arrangement of fixtures for whatever it needs it to be, and another test uses another one.
And the fixture mechanism is really what drew me to pytest. It's the magic that there's a whole bunch of great reasons to use pytest, but the fixtures are what really drew me to it, because this doing all the bookkeeping of keeping track of the setup and teardown for multiple levels within your test system, plus within XUnit, it's really hard to do like something like a session scope, like where for the entire test session, you've got one thing. It kind of restricts you within unittest to be able to do that. That's difficult. Whereas it's really easy in pytest. And for me, I mean, a database connection might be something that a lot of people are familiar with. I do that also with testing software that uses database, but I also test hardware stuff and a connection to a hardware device and setting it into a known state. Those are, and maybe even like setting up a waveform for me to test with it. Those are all expensive procedures that I really don't want to do for every test. They might be up into the seconds to get set up. And then I want to run like hundreds of tests against that without having to do those few second setups between. And that, it was like no brainer. When I learned about fixtures and how easy they are, definitely use pytest. Now, the other thing, setup and teardown are in XUnit style stuff. They're like two different functions. And they used to be like really early when I started using pytest, they were two different functions also, but they're not anymore. The more recent versions of pytest, and this has been for the last couple of years at least, they have actually like the last 5 years. But anyway, there's a yield statement. So your fixture, you can stick a yield statement right in the middle of it. Anything before is your setup. Anything after is your teardown. It looks weird when you first use it, but it's really convenient because I can put this right, like I can use a context expression even and have the yield be in the middle of that or in the middle of really anything.
I even measure the speed of your tests, for example. You can
measure it, or like things that you're keeping track of, local variables within your fixture, they're still there during the teardown. So you don't have to like store it to a global variable or anything like that. So it makes it really convenient.
Yeah. Speaking of data and setting up data, one of the interesting things I found about pytest is the whole parameterization aspect, right? So you can actually set it up so that you write one piece of code and pass in a data structure, and then that generates a whole set of tests that simulate different conditions. So perhaps you could kind of like go into some of how the magic of that happens.
It's pretty amazing, really. So we're talking about parameterization, and there's several different kinds of parameterization within pytest. But let's say the normal function parameterization is I've got a test function that, like, let's say I set up a user and I make sure the user can log into a system, and that's great. But what if the user is different types? So I've got like maybe an editor user type and like an admin type or different roles that I want to test. I can maybe set up all the credential junk that I need for the different roles. I can set that up into a data structure and then pass in an array of different roles to my test and with the parameterization. And then the test runs once for each role. And so in a lot of other, without parameterization, I would have like 3 or 4, or I would have the number of tests that I have, number of roles. Whereas with parameterization, I can just write one test, and it's not like falling off a log. You do have to like work a little bit to make sure that your test is structured such that it can take a named thing like user role and know what the structure is and pull that stuff out and set things up. Now, I just said setup. You can do this all in the test. You can say, okay, well, for a particular role, I want to like go and log in, and then I want to test whether or not, certain accesses work or something like that. Now, if that setup code is complicated, I can push that whole thing up into a fixture, and instead of parameterizing the test, I can parameterize the fixture, and then the test doesn't know that it's being parameterized, but it still looks the same. You can run it. It'll be run multiple times. Now, it really gets blowing up really big if you've got a parameterized test and a parameterized fixture that maybe depends on another fixture that's also parameterized. You can like get a huge number of test cases really fast doing this. So if you're measured, one of your measures is how many test cases you write, this is a really great way to like blow it up and like beat the record for everybody else.
Yeah, it's also a sharp tool, right? If you're not careful, you can have a combinatorially large number of tests, all taking a whole bunch of time in your test suite just because you made a mistake in one place.
But it's also a great way to, if you've got a really cheap test, a really fast test, you can say, instead of trying to pick which test cases to run, you can just, if you've got a fairly small set, you can easily set up an exhaustive test suite that tests every combination. If it ends up being like a huge number, maybe it's not beneficial, but especially when you're developing your code, that might be an interesting thing to just try. Now, things like hypothesis is a different tool that tries to guess good test cases and stuff and input into your test. And you can use hypothesis with pytest to try to guess good input for, input such that it'll break it easily. So hypothesis is pretty good at that. It comes with a pre-built-in plugin for pytest. So that's pretty neat.
Right. So just to dig in a little bit. So hypothesis is a different Python library, but it kind of plugs into pytest, or is this going to be part of that plugin story that we have with pytest?
It's kind of both. Hypothesis is a different category that you can use on its own. You can also use it with unittest, but it comes pre-built with a pytest plugin as part of it. So
yeah, but that kind of leads into the other thing about other kind of superpower with pytest, especially now that it's become so popular, is the extensive amount of plugins and extensions you can kind of get for pytest, right? The other day I was looking for something that I was trying to test something that used Redis, and I found an entire plugin that basically just faked the entire Redis protocol for you, and you could just plug that in. It kind of made it so I didn't have to set up a Redis server anywhere. I could just do the whole thing on my local machine. So what kind of magic does pytest do in terms of the extensibility? What is the kind of maybe a overlying architecture of how that architecture, the plugin architecture works?
Well, there's some under the hood stuff that I don't really understand, but that's okay. I know it extensively as a user would use it. So we're talking about, there's two aspects of the plugin system that are really cool. One of them is it makes it really easy for you as a user to make your own plugin and extend it. So there's a notion of like a local plugin. For instance, we were talking about fixtures, like setting up a database and stuff. Like, let's say I've got like a common database that tons of different like microservices that I have need to access. I can set up a little like my fixtures for how to access it. Normally, I can put those really in the test file, or if I'm sharing it across multiple files, pytest has a notion of a conftest.py. So it's just a naming convention for a file that's used for around the rest of the test suite. But it's kind of also a plugin. So the conftest file is a local plugin, and it doesn't feel like a plugin. I just have my fixtures in it. But I can package that as a plugin fairly easily, and then I can use that plugin. I can have that plugin to be its own Python package, and I can have different test suites in my community or my job or something. They can all use that plugin and use the same fixtures. So I can easily create shared code within my own team or my own organization. So that's amazingly helpful. Now, there's a whole bunch of hook functions we can use too. Like I can hook into so pytest has a hook mechanism that allows you to hook into different parts of how it's running. So after it collects tests, for instance, I can look at the collection before it gets run, and I can maybe modify it, sort it, reorder it, things like that. Now, I also, in the reporting, like there's actually just tons of different parts of how it's working. There's hook functions that you can hook in and look, and it's it's not trivial, a lot of these, to figure out how it's doing this and how to use them, but it's there. And a lot of people have found it useful to figure this out. So as you said, there's a whole bunch of other third-party plugins that have made use of this extensibility mechanism and allow you to do things like I was mentioning during test collection. You might want to reorder them. Well, there's a handful of like plugins that reorder them for you. They randomize them and shift them around. And randomization is a pretty cool thing to do, because if you really don't want the order dependencies within your tests. So occasionally shuffling them around to make sure that they don't break when you reorder them, it's a good idea. Or like you said, it presents these fixture mechanisms for mocking a database or mocking a connection to a server. So you can like mock your requests connection, or you can record things. There's plugins to record and playback sessions. And there's all sorts of stuff you can do with the plugin system. And it's really pretty easy to set up. It's one of the things, like one of the reasons why I said it in the pytest book that I wrote. There's a dedicated chapter on how to do this, because when you go with a simple example, it's easy to see that it's really not that hard to do. And especially with a local organization, I think it's important for people to be able to share code, even if they never publish on PyPI, it's just shared within their organization.
Yeah, I think that's a great point. Just to kind of go into another concept that you kind of talked about there a little bit, which is the idea of mocking. So, can you tell us what is mocking and why is it used? What is its function in testing?
Well, mostly it's to make fun of people. I think.
Yeah, in addition to that.
Well, so there's a whole ecosystem around mocking and a whole bunch of words. It kind of gets confusing when you're in other places. But within Python, we usually get our mocks started with the unittest library. So there's a built-in mock mechanism that's now part of the unittest library. So even if you're using pytest, if you're using mock, if you want to mock something, we get it from the unittest mock library. But anyway, the idea is it's part of your system. You want to like not use the real thing. You want to use a fake thing. And there's lots of reasons why you might want to do that. Like you said, like a Redis server, or maybe I've got access to my customer database or access to a third-party system like Stripe and charging credit cards and stuff like that. And when I'm running my tests, I really don't want to like hit those things. Maybe I do if it's my my Redis server, if it's local, maybe I do want to test that. But I can, mock that out and avoid that. So especially if I don't really care about the logic of that logic right now. The thing I'm focusing on maybe is the user interface experience or something else. And I want to isolate part of the system away. So mocking can be done with that. And Python's like a very dynamic language. So it's fairly easy to say, after you've got a system loaded, hey, this one piece in here, don't use that piece. Use this new fake piece. So mocking is great at that. Now, the other reason to use it is, like, let's say it's not that I just don't want to talk to my Stripe server or something, but I want to make sure that the code that's hitting the Stripe system is doing it correctly. So mocking allows us to interrogate the calls to say, okay, I'm going to use this fake Stripe system, but when this bit of code runs, after it runs, I want to make sure that the Stripe API calls were called at the right time with the right content.
With the right data. So it allows you kind of look into the request that you're sending to the Stripe API and making sure that that's correct.
Yeah, super powerful and handy. Yeah.
So, and this is just a curiosity. So you said you test hardware. I'm surprised. Do you not use mocks for hardware?
Well, that would defeat the point because I'm trying to test the hardware.
I've often heard that, a lot of hardware testing uses software simulation of the actual hardware, especially when it is pre-production stuff.
Maybe. I usually want to make sure that the entire thing's working. So I don't mock very much. But like for something, so mocking is often used for doing these like hitting parts of the system that you don't want to do. I do want to say I don't really like using mocks. And I think that there's an architecture problem if you have to use it. And I would say that the things that we don't want to hit during testing, that should be part of the architecture known at creation time. So we say, hey, we've got a Stripe system. We know we're going to want to test this system. We don't want to hit Stripe all the time, or we don't want to hit email all the time. So designing the system, and coming from hardware also, there's a notion of designing for test or designing for testability. And software can do this too, to know, hey, there's parts of our system that we're probably not going to want to hit during testing. So how do we verify the rest of the system is working correctly? So one way for like maybe an email system or something would be design into it a switch to say, hey, turn the email system into, instead of actually sending the email, just log it to a internal memory buffer.
Into a file or something. Yeah, okay.
Yeah. And then the test can interrogate that and check the contents to make sure that like the sender was correct or whatever, if they want to. And the same with the Stripe server or something like that. You can have like a stub one in place, but it doesn't necessarily have to be like, it can be during debug only, but it also could just be, that's part of your system, is to switch it out. The other aspect is maybe that's dangerous and we really do want to have mocks, but let's make sure that like instead of a Stripe system I'm talking to, I would have like a part of my architecture that's the payment gateway. And it's just like one file or one module that it's the only thing that ever talks to Stripe. And then it's a known API that I have control over. So that thing I can maybe test against a Stripe test database and make sure that that one little tiny API to this payment gateway is working correctly, that actually hits something. But I don't really change that API at all, ever. And then the rest of the system can mock, instead of mocking or stubbing Stripe, I can mock my payment gateway with a fake one. And that's more safe because I know it's never going to change. Now, there's a built-in part of the mocking library that some people forget about, which is the ability to auto-spec, where you, instead of just saying, I want a mock thing, if you just say, by default, mocks will accept anything you pass at them. But if you auto-spec them, then it will force it to only accept the API as is. So if the API ever changes, then it won't accept things that don't match the API. So that's a good
thing. So I think it's called spec, and it kind of like you can specify the attributes and you can put in some values for what is the API like.
Software engineers, you've been there. Something's broken and you and your whole team are scrambling to find and fix it. That's why you need New Relic. It combines 16 different monitoring products so you can see across your entire software stack. It pinpoints issues down to the line of code so you know exactly why the problem happened and can fix it quick. Get access to the whole New Relic platform and 100 gigs of data free right now at newrelic.com/SERadio. That's newrelic.com/SERadio.
So just to dig into the architectural aspect that you mentioned, I think that's a great notion, the idea of designing for testing, right? And so if you wanted to go about, if I'm a developer who's only written like Python scripts, right? One-off scripts for automating things and all that. And then suddenly I get hired into a new startup and then they say, hey, Nikhil, we're going to build this e-commerce website and we're going to do it in Python. And I want you to build this whole thing out, right? So I'm suddenly staring at this blank canvas with a folder in it, and I need to build a project structure. Do you have any tips or do you have any thoughts about how we can go about designing a project, or even if you have an existing project, how do you actually build it in a way or re-architect it in a way that makes it test friendly, especially for pytest testing?
Yeah, there's a lot of tips, but first off, I got to say congratulations on your interview skills for landing this job that you're clearly not qualified for. So Kudos, but we can get you there. So one of the first things, like going from a normal script. So when I say script, often it can really be anything, but some of the beginning Python scripts that I wrote, there was no functions at all in there. There was no dunder main or anything. It was just code that ran when you ran it. Now, the first thing is don't do that. So even if you take like the entire contents of that file that you're used to and stick it in a main method and then have a dunder method, like there's a thing called that we're conventional.
Double underscore, yeah.
Yeah. If double underscore name equals double underscore main in a string, it's a thing Python does to tell your script that this code is running because somebody said Python, your script name, versus importing it. That little switch makes it so that you can both run it as a script, but you can also import it. And now that it's importable, I can write a test. So I can write a test that imports my module and then runs the main method and hopefully checks the output of it. So code, and then maybe, having a 7,000 line file all stuck in one main method is probably a bad idea. So breaking your code into different functions, different modules is a good thing because then I can test individual pieces. It's a lot easier to test pieces than the whole thing. Actually, it's not. But if you've got a chunk of logic, it's easier to test in a small function. One of the things I get a lot of questions of like, how do I test this thing? Whether it's like, this server or whatever. The first questions I need to try to ask somebody is, how do you know it's working? And if you can't answer that, if you don't know what the behavior is that's expected, what the output's supposed to be, and what like side effects happen, there's no way you can test it, because that's essentially all testing is checking to make sure that the behavior is as expected and the side effects are as expected. So
that's interesting. So that kind of puts me on mind too. So what is your opinion about test-driven development? Because I would imagine that's something which is where you have to write the test first and then write the code that satisfies the tests, would mean that you'd have to think about side effects and how to test, how to tell if something's running upfront, right?
Yeah, definitely.
Yeah. So you're a fan of test-driven development?
I'm aware of test-driven development. So I am a fan of test-driven development, but the thing that I call test-driven development is different than what a lot of people use. So there's really like two flavors. There's lots of flavors, but there's an original notion of test-driven development, which is using tests to help you develop your system over the course of time. Now, then there was this other thing that is focused on testing little tiny pieces, and then that's like the mock-driven, test-driven development, which is something that developed later, and I never got on board with that. But developing both tests and code at the same time, especially as you're developing production code, I'm definitely a fan of that. But I'm not a stickler for the test has to be first. There's tons of times where I'm like developing a feature where I'm just playing with it, that I don't necessarily write the test first. I also write a lot of tests that I throw away. So I use testing for just playing. So one of the things that people will often do when they're developing code is, like, if you're developing a bunch of functions within a module, say, I want to call those functions to see what they do. And one of the easiest ways to do that is to write a test that calls that function to see what it does. And you can even just, with modern editors, you can just like select that test file and say test and say run. Without a test, you'd have to write a specific file just to call that one function. Whereas with a test, you can have like a whole slew of little helper tests just to try things out. So I write exactly. A ton of those.
Yeah, I mean, I'm reminded of the fact when I was getting into the business as a junior developer in a .NET project, I had precisely this problem, right? I had this thing where I was given a task to do and I had a set of functions written and I was like, okay, now how do I actually run this? And the way I did it was basically wrote a main and then debugged through it on Visual Studio, right? And then basically I got one of my seniors came around and he was like, hey, why don't we just write a test and run it in the context of the test framework, and then you don't have to throw away the main function at the end of the day. You can actually use it as tests, and that was great advice.
How a lot of people start this whole like if name equals main thing in your module. Some people will just stick like calls to their code in there and even assert methods or whatever. But it's just, I mean, it's not maintainable over time to keep those running. So don't be afraid, especially for exploratory stuff like that. Don't be afraid to throw those away. I mean, or keep them if they're helpful. But sometimes it was just there for me to learn what the problem space looks like. You alluded to, I want to come back to a little bit. You alluded to the fact of if you're only used to running small systems and you want to create a bigger system, that's like a computer science concept of which in like small letters of one of the big tricks that we have as programmers is taking a big problem and breaking the problem into smaller pieces and then focusing on those pieces. Now that's one of the miracles of testing is I can have my test focused at when I've broken things into smaller pieces, I can write the tests around those pieces to say, I think I want this piece to do this. Now I'll write some tests to make sure that it does that. And then I can forget about it. And then I can go focus my attention on the different pieces.
Yeah, but to kind of take the reason why I said that, or rather brought up that particular question, was that oftentimes I have seen in my experience as well, where people would go about without tests or not considering tests, build huge systems that are very connected and coupled, right? And I've always found that if they had started out with tests in, like you said, small pieces that you write a test for and then you write another test for, it almost kind of evolves into modular code somehow, right? I think that's kind of one of the side effects of having to think that, okay, when I'm writing the code, how do I actually make it so that it is isolatable and testable, that you naturally tend towards a modular design rather than, building large systems which kind of like are all connected together.
I've heard that claim also. I haven't seen it as an example. I've seen working code that is a mess, and I've seen messy code that works, and vice versa. So I think hopefully if you get used to breaking problems down, you're going to naturally modularize things. And it also has the advantage of being able to write tests around it. Also, one of the benefits of the tests is that it allows you to rewrite stuff. So once you've figured out a problem, you can look at it and go, gosh, this code is a mess. I mean, I figured it out, but it's a mess. And I can go and rewrite it to where I'm proud of it. And then my tests verify that I didn't break anything.
Yeah, absolutely. Yeah, that's the classic red-green refactor cycle, right? So the refactor part comes because you already written the test and you have a framework in which you can change the structure of the code with confidence. So yeah, which brings another point up. So there's obviously the ideal situation is that, you'll write code and your test throw an error and the error is because your code failed or you made a mistake or you have to correct something. But there's also the other situation, right? When you have to write a new feature or you have to change the code for whatever business logic and your test is now wrong, right? And there's always a balance there. So I've also seen situations where people basically say that, okay, you need to have a lot of code coverage, you need 100% code coverage. And I've also seen situations where that actually leads to a thing where you cannot change your code because as soon as you change one place in the code, 1,000 tests are broken and you have to go and fix all of that, right? So is that kind of like a sign? Is there kind of like any design practices or any design recommendations on how to design a test suite so that it is similar, it is not so brittle and it doesn't kind of break everywhere?
Well, there's a few things about that. So yes, there's ways. Well, the primary way is to focus on behavior, testing behavior instead of implementation. So hopefully I partly write the test so that I can change the code, so that I can rewrite chunks to make it maybe something I'm proud of, or just because it's fun. It's sometimes fun to rewrite chunks. If the code is changing because the behavior has changed, then hopefully tests will fail because they're testing for the old behavior. And so, yeah, we want that to happen. The other side is if instead of testing behavior, I'm really testing implementation, that's kind of where that's also one of the dangers of mocks is utilizing mocks a lot in your system might cement you into one way of doing something. So be careful around that. Things like a payment gateway, mocking that, I know I'm going to want to mock the payment gateway. So it's okay that's a known, you made a decision to do that. But I wouldn't mock all over the place just so that I can isolate a function from its dependencies if the dependencies are part of my system also, because I want to be able to change the implementation and do something else. One of the problems often with brittle tests is because they're testing implementation and not behavior. And so then if you change the implementation, your test breaks. We don't want that. The other aspect of it is user interface components. So testing around UI components is a design thing, and that's difficult. So I generally don't write very many tests around a user interface. I like to test against an API instead. Those are often less brittle. But if you've got like workflow stuff, like if I've got like lots of ways you could use the system, and so I've got a lot of different workflows tested at a high level for the whole system with a database and everything, and thinking that those are brittle, that's like your customer. That's how your customers use it. So if those tests break when you just refactor something, your customers are going to break also. So there's a problem in your system.
Yeah, yeah. No, I hear you. So it basically, like you said, it depends on what kind of tests are breaking, whether it is a group of implementation focused tests like the UI or something like that versus, you're testing multiple different ways to use your API and you change your API and then all of them break because, well, that was a big change to a contract that you have for all your interfaces. So that's a great point. But okay, let's take it another slightly different tack. So now I have a failing test, or I'm running a large test suite and I get a failing test, right? And pytest basically says, okay, there is a big red dot over there, and it says, okay, it's failing, and this is not equal to that. Is there a way to kind of get more information about what is failing? Can I kind of like focus on to a particular test or a particular way to kind of debug into it and kind of figure out what happened?
So hopefully it fails again. So have you heard the joke about the software engineer in the car? So there's like 3 engineers in a car. They're going down a hill and the brakes give out and they can't stop. They finally stop the car and they're worried about it. The hardware engineer says, well, clearly it's a brake problem. We should investigate the brake system. And the electrical engineer says, I think the mechanism to indicate that we're braking might be broken, so we should check the electrical system. And the software engineer says, before we do anything, we should push it up to the top of the hill and see if it does it a second time. So in software, we try to reproduce the problems. And so one of the cool features that I like around pytest is a last failed system. So it's always keeping track of what's going on, of which test passed and failed. And especially the failures, it's going to have a list of those. So that's already built into the system to keep track of that. And we can use a flag, it's LF or last failed. And there's a bunch of other ones around that, like failed first or stuff like that. But I can say just rerun the last failed ones. But one of the benefits of that is when I rerun the last failures, I can have more control over it. So like I can say, give it a -X for fail up, don't run more than one. Like find the first failure and just stop there. And then I can say like verbose. I can have it be more verbose. And I can say things, and that just gives me more traceback. It fills up the traceback more. I also can have control over the traceback. I can say I want a short traceback or a long one or the full one. And then the one I really love also is to show locals. So when a test to have during the traceback, also print out all the local variables and what their contents are. It's really handy to be able to rerun that again. And then for big suites, there's a stepwise that came in a couple versions ago that I really love using, to where I can say, instead of just doing the last failed, I can step through a suite. So I'm going to run the suite until it hits a failure, then it stops. And then I can maybe change some code or change the test or add some more debugging. And then I run it again with the same stepwise. And instead of starting at the top, it starts at that last failure and just reruns that. If that passes, well, if it fails, it just stops again. But if it passes, it continues to the next failure. So it just keeps on stepping through to all the next failures. It's really handy.
Very cool. Yeah, very cool. That's actually something I did not know. I'm going to try it out next. So obviously, pytest is a tool that we can run on the CLI, and it's a standard scripting tool. Is there any special considerations that we need to think about when we're going to try and put it into maybe our CI/CD pipeline? Does it have any dependencies that need to be worried about, or can we just use it as a part of the Python requirements file and you're done?
I usually separate them out to have not as the requirements for the system, but have test requirements. So either a separate requirements file. So some people do that of like two different, for an application. If you're using requirements, you could have a separate requirements. It's usually called dev though, because we want our developers to have it also. But CI system can load that. Or there is, like if it's a package project, you can have extra dependencies. So I can say like, pip install foo with brackets in it test or something, and then it brings in the test requirements. So those are ways you can do that. But then other people just have that as part of their CI pipeline to say, hey, it's going to have to bring in pytest, so pull that in.
Right. Is there kind of like, I remember you mentioned in your book, there is this tool called Tox that you can use for testing various versions of Python and managing environments and stuff. How does that kind of fit into the whole pytest story, testing story?
I like to use them together, but there's other versions you can do. But so in CI, like continuous integration, you've got the server running your tests. But you can do something similar locally with Tox. Nox is another option as well, but I particularly like Tox. And traditionally, it's around testing multiple versions of Python. So if I've got, like, let's say I'm developing a library, I want to test it against several versions of Python, I have to have those versions loaded on my computer for this to work. But if I can set up talks such that it will create virtual environments with multiple versions of Python, and then build not just load my software, but build it in those versions, load it, and then run them and test everything out, run my tests within that environment. I can also make it just do build once and then test against that. And actually, I probably misspoke. I think it just does it build once. But it's like a CI pipeline on your desktop so that you can test a whole bunch of stuff out. So that's really handy to be able to test out. You don't have to do it against multiple versions of Python, though. It could be something else. Like, let's say I am writing a Django plugin and I want to test it against multiple versions of Django. I can set up talks to do that, to test on multiple versions. And then, within pytest, it's kind of fun. I didn't learn this until I was writing the second version of the book, is there's a cool way that you can use talks and pytest together to debug just a single talks environment. So, like, let's say pytest, Python 3.10 is breaking for your package. You can rerun and set up all those extra flags like the show locals and all that stuff. You can pass those in and just set it to one environment, which is pretty handy. Or you can use PDB and step through it just right there. So.
Right. Great. So I think we're kind of like reaching towards the end of our discussion here. Is there anything that we missed that you would particularly like to talk about in terms of our discussion?
Yeah, one of the things I really want to, we brought up test-driven development once, or for a little while. One of the things in a lot of the TDD discussions talk about is testing your code is worth it. I believe that. They also say when you start doing it, developing with tests is slower, but it's worth it because you'll have less maintenance in the future. And I just don't buy it. If I think developing with tests is faster than developing without tests, I don't think it's slower.
That's an interesting hypothesis. Is that based on your experience, or is that why do you say that it is faster?
Because I'm doing it anyway. So I'm like, let's say, like you said, if I'm writing like a main function to call my functions, writing tests to call my functions is easier. And it's not that big of a leap to go, okay, what tests did I write just to develop the thing? I probably can spend like 45 minutes and clean these up, and they'd be a decent test suite for my system and to begin with. And then I've got checking it in. So I'm helping tests to run my code while I'm developing it. I'm using tests to help make sure it doesn't break in the future. I don't think it takes long for you to learn testing and be comfortable with it enough to where you're actually developing faster than you would without tests.
Yeah, I tend to agree, even especially with a framework like pytest, which is so flexible, and like you said, it's so easy to do it that you almost feel tempted that it's such a beautiful way to do it. You feel like you wanted to write some tests. So yeah, that's a great point. So just in terms of completeness, so how can our audience follow or connect with you? I believe you are already a podcast host and you have a couple of podcasts. We will add links to those podcasts here, but maybe you want to talk a little bit about other ways and maybe a little bit about the podcast as well.
Sure. The primary way. I hang out on Twitter a lot. So I'm at Brian Okken on Twitter. And then I've got test and code, which I have to enunciate because some people think I'm saying testing code. It's testandcode.com. And then also the Python Bytes podcast, which is at pythonbytes.fm. Those are the two podcasts. Yeah, and Twitter. One of the fun things about the test and code community is we have a Slack channel too. So there's a Slack channel you can sign up for, and there's like hundreds of people hanging out, asking and answering questions around testing, especially around pytest, but they'll around other Python topics too. Like if you've got some weird database that you're connecting to and you don't know how to test it, there's probably somebody in there that's using it also. It's pretty great. And then I've started blogging again. I started this whole thing by blogging and I'm doing it again. It's at pythontest.com.
Awesome. Thank you so much, Brian. It was a great discussion. I'm sure our audience would be looking forward to reading more about it on your book, which is Python Testing with PyTest. and it's from the Pragmatic Programmers Press, which is, again, one of my favorite publishers as well. So thank you again, Brian.
Oh, thank you.
On.
I want to add one more note. The second edition also was written such that it feels like a course, and that's on purpose because I do want to turn it into a video course. So that's one of the things I'll be working on this year, is turning it into a video course.
Awesome. Okay. Good luck on that. We're looking forward to it.
Thanks. And thanks for having me on the show. This was fun.
Okay.
Thanks for listening to SE Radio, an educational program brought to you by IEEE Software Magazine. For more about the podcast, including other episodes, visit our website at se-radio.net. To provide feedback, you can comment on each episode on the website or reach us on LinkedIn, Facebook, Twitter, or through our Slack channel at seradio.slack.com. You can also email us at team@se-radio.net. This and all other episodes of SE Radio is licensed under Creative Commons License 2.5. Thanks for listening.